So the first thing I need to do is define a sequence. Okay, so in your notes, a sequence is a group of numbers separated by commas. Yes, Sierra.
Are we doing the extension related geometric sequences to exponential?
And the one before that first. We're doing two extensions. So we're on page 477. Yeah, 477 and 479. Those are the things we're going to be talking about. But in order for us to talk about sequences, we must know what a sequence is. And a sequence is just a group of numbers separated by a comma.
So like 5, 8, 7.
Okay? Yes. Any group of numbers separated by a comma is a sequence. There are two special kinds of sequences that we want to talk about. Okay? There are two special kinds of sequences that we want to talk about. And you look very confused.
I'm trying to, I think what spelled separated. Did you do something with my book? Right. No, with
Right.
my notebook.
Why would he have your notebook?
Okay? So, there are two special types. The first type is arithmetic. It's a word that is spelled there are two words spelled the same but pronounced differently, like read and read.
What is arithmetic?
Okay, arithmetic is a verb. Quiet, please. Arithmetic is a verb. Arithmetic is the process of doing the math. This is the description of the math. This is a noun.
So you have to determine which is...
Yes, so this is a noun, so it's arithmetic. The arithmetic that you do is a verb. Arithmetic is a verb. This is a noun. Yes?
Wouldn't it just be easier to understand if you turn the E in between the M and the E?
No.
It sounds better.
Okay, but so if it's an arithmetic sequence, there is a common difference between each number.
Like 3, 6, 9, 8.
No, not 3, 6, 9, 8. 3, 6, 9, 12, yes.
Why did I say 8? 3, 6, 9, 8. 1, 2, 7, 8.
So that would be an arithmetic sequence, 3, 6, 9, 12, like she tried to do. And then 1, 3, 5, 7, 9, 11, 13. So an arithmetic sequence has a common difference. And the way we find the difference is we take a right-hand number and subtract a left-hand number. And I don't want to call this like A, B, C, D, E, F, G, use a different variable each time. So the way they do that is they're going to call this the first variable that we call like A sub 0, where 0 means initial. Then the second variable would be A sub 1, then A sub 2, then A sub 3. Because I can have more than 26 variables, which would mean I'd have to have more than 26 letters. So this way I can get by with just using a single letter for all of my variables. And again, if I have more than 26, you are going to run out of letters.
Is that negative A?
Shh. So the way you find out a difference is you take a number and you subtract the number just to the left of it. What is 3 minus 1? What is 5 minus 3? And 7 minus 5?
Wait, so the answer is 7 minus 5 equals 2?
No. There is no answer yet.
It's a sequence. It's 2.
I'm showing you the what a sequence looks like. This is a common difference. I found the difference in between a group of numbers.
Yeah, same difference.
Shh. What you're going to find out, these are called the first differences. Later on this year, we're going to come up with an we're going to come up with a sequence that the first differences are different, but the second differences are the same. And we're going to do that towards the end of this year. Any questions on arithmetic sequences? An arithmetic sequence can be rewritten as a general equation where the nth term, like the 7th term, whatever number I want to put in for n, is equal to the first term plus the common difference times n. Shh. Actually, it's n minus 1.
Would you distribute it?
No, I'm done. This is the way I want to write it. This is how much I change going from one number to another. What do I call the change when I go from one x to another x on a graph? What? The slope. This is the slope. This is my initial number.
Wait,
When
the
x is 0.
So this
Shh.
0?
No, that's the d. Common difference. That's the amount of change I go from one number to the next. We call that slope. This is my initial number when x is 0. When x is 0, what do we call that part on a graph? When x is 0, what do I call this point on my graph? The y-intercept. I've got a y-intercept and I got a slope times a number. What does that look like? It looks like a linear equation. Arithmetic sequences give us linear functions.
Okay, will you plug in those numbers you have on the board?
Shh, I'm going to do some examples, so please wait. What is my first number? What's a sub 0 in this sequence? What's the first number in this sequence? What's my common difference in this sequence? If I wanted to know the 5th number of the sequence, so if I wanted to know the... So it would be a sub 0, so I'm going to write a sub 0 plus d times n minus 1. So I want to know a sub 5. So a sub 0 is 1, d is 2, 5 minus 1. What's 5 minus 1? And that's 8. And 1 plus 8 is 9. Is a sub 5 equal to 9? A sub 1, 2, 3, 4, 5.
You see that? That's called math.
Question.
Hand up.
Yes.
Okay. Is there ever going to be a time that we're going to be doing it where the n is going to stay a variable and then we have to solve?
N is a variable. Well, so no, you're not going to solve for n right now.
Just a place.
Let's say I wanted to know the 100th term of this sequence.
Wait.
If you want to know the 100th term for this sequence, just put 100 in here. Okay, what's 100 minus 1? 99 times 2.
8. It's like 3. It's 198.
Okay, yes it is.
It is. They're both minus 1.
Okay, and then 198 plus 1? 198 plus 1? So that's how you can find a term that's way on out there in the sequence. That's what this relationship is for. So if I give you a sequence, you should be able to write this type of formula. That's its general rule. Any questions on arithmetic sequences?
If we do like a problem that
I will after I go over the next type of sequence. Please sit down, Sierra. Next type of sequence is geometric. A geometric sequence has a common ratio. Correct. Or it's 2 times this number, which is 2 times this number, which is 2 times this number.
So it's 10 to
Exactly. So we're
That's really scary.
You got really happy.
No, where an arithmetic sequence gives us a linear equation, we should know from last week that, hey, we had the same common ratio type of idea when we were doing our exponential equations. Instead of getting a linear function, this one's going to give us an exponential function. No, I've also been happy the other times that she's caught on to some of the extensions. The reason why these...
That doesn't happen very often.
The reason why these things are extensions is they're things that you should be able to realize based off of the previous work.
We'll make those in our thing.
So what this is saying is the nth term of a geometric sequence is the first term times the common ratio to the n minus 1. For example, a geometric sequence would be this one. So how do I find the common ratio? I take a term and divide it by the term to the left. What is 4 over 8? 1/2. So if I wanted to know the 6th term of this sequence, actually let's do the 7th term of the sequence, because I've already got the 6th. So watch this. A sub 6, I said 7. A sub 7 is the first term. What's the first term?
8.
Times the ratio, 1/2, to the 7 minus 1, which is 8 times 1/2 to the 6th. What is 2 to the 6th? It's 1/64.
4 times 2 is
So 2, 4, 8, 16, 32, 64. Powers of 2 you should be able to do in your hand. Okay, and 8 over 64 is 1 over 8. And does that look like that's what it would be for the next term over here?
Does that say A1?
Yes, A1, which is the first term.
Which is this one? It's also the name of my dad's landscaping company.
Okay, any questions on geometric sequences?
No.
They come from common ratios. Arithmetic sequences come from common differences.
Yes.
For right now, those will be the only 2 types of sequences we come up with. If you cannot come up with a common ratio or a common difference, then you're going to say, hey, it's neither. It's not arithmetic or geometric.
What is it then?
It's nothing.
Right now, you can't say it's nothing. You can just say it's not arithmetic and it's not geometric. Later on this year, like I said, we're going to do things that have the second differences, and we're going to talk about what kind of sequences those are a little bit later this year. Shh. No? Just waiting for it to be quiet. So the next thing we want to do is we want to talk about recursion.
What is that?
The best way to talk about it is by doing an example.
Do an example.
Okay? A recursive rule gives the beginning terms of a sequence and an equation to tell how the next term comes from the previous term. So a recursion. It gives the first term or terms of a and equation to come up with next terms in terms of previous ones. That's a definition of a recursive type equation. I'm going to give you a couple examples of recursive types equations. So here's a recursive type of equation. I tell you the first term is 1. I tell you the second term is 1. I tell you every term from the third and beyond is equal to the sum of the previous two terms. For example, if I put a 3 in here, what is 3 minus 1?
2.
And what is 3 minus 2?
1.
So the third term is equal to the second term plus the first term.
What? 2 minus 1 is 4?
The fourth term is equal to the third term plus the second term. So let's come up with the first, let's say, 6 terms of this sequence. What's a sub 1?
1.
It's 1. I told it to you. What's a sub 2?
1.
Okay, a sub 3. A sub 3 is equal to a sub 2 plus a sub 1. What's a sub 2?
2.
What's a sub 1? So this is 2.
Just sounds like it's saying ace.
What?
Ace 1.
How do
Ace 1.
See this in?
Yeah.
What's my in?
3.
3. So I have the third term is equal to what's 3 minus 1? 2, which is the second term. 3 minus 2 is 1, which is the first term.
Yeah, I thought that was a Z.
Z's do not look like that when I write them down in class. They have a line through them.
Wait, wouldn't a sub 4 be 2 as well?
Well, a sub 4 is the third term plus the second term. What's the third term?
2.
What's the second term?
1.
Which is?
2 minus 1.
It's not minus. The fourth term is equal to the 4 minus 1, which is 3, and the 4 minus 2, which is?
2.
A term is equal to the sum of the previous two terms. The fourth term, so this one's 3. The fifth term,
4. It's 5.
it's 5. The previous terms, 3 plus 2 is?
So really you don't need that confusing equation.
Well, that's where I'm getting, I use the confusing equation to come up with something in words that I can do. The sixth term,
8. 13.
does anybody recognize this sequence?
No.
I'll tell you it's not prime because
It's not prime.
neither is 8.
8. Or 2.
Have you guys covered the Fibonacci?
That, aha.
That's it right there.
Like it starts with a P.
It starts with an F.
I know, but that's what I was thinking.
So that's the Fibonacci sequence.
What is that?
It's something. It's like if you count the number. So if you look at the spiral inside of like a sunflower, or the like the number of like sunflower seeds as it goes around in a sunflower, it follows that pattern. Pine cones. If you start at the very tippity top of a pine cone and the number of things going around the edge of a pine cone.
That makes sense.
But some of them have less than 1.
So like the rings on each layer.
Yes. So that's
How many on each layer is from the first?
yes. So that's how it. This is how. And a lot of times you'll see it start out like this: 1, 2. But in order to come up with a recursive sequence, you'll define the first two terms as 1.
Okay, so recursive is if there's a repeating first term.
Yeah. So a recursive means I can write an equation based off of previous numbers. Gives the first given the first term, that should be a given. Given the first terms of a sequence and an equation to come up with the next terms. So you're always going to have this term is equal to something previously.
So anything can be a recursion.
Yes, and I'm going to show you examples of recursive arithmetic sequences and recursive geometric sequences. This one is just fun because you guys should have seen this one before, Fibonacci. This is neither arithmetic nor geometric.
Yeah, because it's just random numbers.
They're not random, they're natural. things in nature. So the recursive sequence for arithmetic looks as follows.
Arithmetic.
What it says is to get any the next number, I take the previous number and add the difference to it. Does that make sense? Yes. I take the previous number and add the difference to it.
Did you freeze that, or did you just
We drew some lines.
Wait, equals 1. So that's just going to be... Why did you...
That's n minus 1. That's not an equal sign.
I can erase some under that.
So here we go. A sub n is equal to get a number. A sub n minus 1 means previous number. In words, that's what those things mean. A sub number, to get the nth number, the fifth number. If a sub 5 would be to get the fifth number, I would take the, what's the previous number from 5? 4. I'd use the fourth number and add the common difference. For a geometric sequence, I would take the previous number and multiply it by the ratio. So, here's an arithmetic thing. They tell me the first number is 5. They tell me the common difference is 5. I want to know the first 5 terms.
5, 10, 15, 20, 25, 30.
So the first term I know is... To get the second term, I take the first term and add 5.
Plus 5.
Is?
10.
Add 5.
15.
Add 5.
25, 30, 35.
And I only wanted the first 5.
50, 55, 60, 65, 70.
Calm down. 85, 90.
What's the first term of this geometric sequence?
1.
Because they told it to you. What's the second term?
2.
Yes, the first term times.
2.
This one is going to be this number times,
2.
which is?
4.
Next.
8.
Okay. Any questions on coming up with a certain number of terms using a recursive sequence? Now you've had them. Because it's n minus 1 means the previous number, and that's the definition of recursion. I find the next number by using the previous number, or numbers. This means previous number. If a sub n is the number, this is the previous number.
Is that R just chilling, or is it...
That's an R. It's a multiple.
Exponent. Oh, it's just...
If a sub n is the number that you want, a sub n minus 1 would be the previous number.
Oh, I thought that was an exponent.
No, it's not an exponent. It's a subscript.
R?
No, that's not an exponent. That's a multiply.
That's what I asked.
Why do you feel
Your
taken
pants
out?
look blue for a second. I don't know why.
Quiet, please. Arithmetic or geometric?
All of the above.
Arithmetic.
Okay, write a recursive rule for that sequence. Write a recursive rule for that sequence.
Wait,
Hold on. Look, have you...
There's only one number you got to fill in, people.
is it
2, 5.
It's 3. I'm stuck.
What letter am I filling in for 3 here?
N.
It's
A.
17.
A.
It's That was the last to guess.
Putting A.
That's all you do, is you write down the first term, and then you write down the equation with the common difference. So if I ask you to define an equation recursively, you've got to write down the first term or terms, and then give me the equation.
My ankle's still fat.
Don't
Wait.
worry, I'm fat.
Hold on.
Where do you plug in the A1? I'm so confused.
I'm not plugging anything in.
But the A1 equals 2, doesn't that go into...
That's the first term.
Yeah.
Yeah, you just times everything.
They're telling you what the first term is. I have to have somewhere to start.
Okay, you see the D?
Yes.
You just add everything by 3 because
You have, so, quiet please. In order to write a recursive statement, you have to give me the first term and then an equation. What's the first term?
2.
2. And then the equation. Take the previous number and add 3.
So 2 minus 1 plus 3. That's 4.
No, it's,
2.
There's a minus 1.
this is n minus 1.
Yeah.
So this would be a sub 2 equals a sub 1 plus 3. What's a sub 1?
1, 2,
And what's 2 plus 3?
5.
5.
Okay, so you plug in the number they gave you into the n minus 1. If you did it the equation way.
Yes.
Instead of using your common sense, because this is going to be...
It's because you're not making the effort. You are plugging in a number for n. That's all you're doing. So if I put a 5 in for n, what would this equation become?
Then it would be a n minus 1, which is 4. So a would be 4.
No, a would not be 4. It would be a sub 4.
Which would
This
be
says the 5th
plus
term
3.
is equal to the 4th term plus 3. 1, 2, 3, 4. 4th term plus 3.
Hey, the blondie over there didn't get it either. Does she not put in effort?
Put in there.
No, I didn't realize you did that. I realized that. She's not that bad.
That's just common sense. Like, why do you need an equation for that?
What did you realize?
Because you're going to find out when you get to Algebra 2 that this is a lot easier to write and a lot easier to do some math on than it is to write out every number.
Actually, I like this.
It's 1/3.
Wings back.
Or light, it's 1/2.
Oh my gosh.
I had wings back.
No, it's 2.
So is this geometric or arithmetic?
Wait, Eric, why didn't it go 2, 4, 8, 16, 32?
Okay.
That's geometric.
Oh, I was thinking.
And it's 2.
Because she's right.
Ha.
It's geometric.
That's what I said.
So I need to know the first term. What's the first term?
3.
3.
What is the common ratio?
2. Isn't that 2?
How do you find the common ratio? You take this number, divide it by this. It's 1/2.
I was like, I don't know.
And
Earlier.
what I need to do to write my geometric sequence is I need the first term, I need the ratio, and then I can write my equation. The next term is equal to the previous term times the common ratio. And my common ratio is 1/2. So I'll just put a 1/2 in front instead of putting it at the end. So this says the next term is equal to the previous term times 1/2.
Oh, I see.
Plus 1.
Times 1/2.
Oh, a geometric is time?
Yes.
Oh my god, guess what? Are we all done?
Okay, we'll just do that.
Why is it here?
Stop.
Why'd you do that?
Massage and maybe I'll like,
That's not a mistake.
Oh, wait.
you took it out of his head.
No, it's good.
Oh.
Why is it?
So the homework for the extension is page 478, 1 to 9, page 481, 1 to 23 odd, and 26. This is due Tuesday. Yep, which is the 12th.
Oh man, no, it's gonna be really tough.
Hey, you want to see my sister Puppy? Okay.
They were born like yesterday or the day before.
Can I go to the bathroom now, please?
Almost. Your Chapter 7 test prep
You're gonna make me cry.
is page 489 all.
Wait, what is that 26?
It's a 26.
Oh, God.
That is due Wednesday. The Chapter 7 test prep. You have a test on Wednesday.
Why does it say
Why did
red?
it say 26?
Because you have to do the 26.
Oh.
It says Chapter 7 test prep.
Prep.
3, 4, Tuesday, 2,
All. Dang, 18.
Come here.
So, the recursive stuff is due tomorrow.
212, not 218, you dumb hoe.
Okay, and then the Chapter 7 test prep is due Wednesday. You have a test on Wednesday over Chapter 7.
Okie dokie,
Are you done recording?
Are choking?